Hello, I'm going to walk you through exercises on BLAST and sequence alignment in UNIPROT. 1. In the UNIPROT entry for the human hexokinase 1, perform a BLAST search. So before we look at any further questions regarding the results, let's just set it up. And we need to go to UNIPROT in a new browser window. And then we can enter our search terms. Let's just take the whole thing, human hexokinase 1. And in the results, the first entry is P19367, which is a good one. And we can perform the BLAST by going to BLAST. Not having any further instructions, we use the default settings. So that will start the BLAST search, and we have to wait until results show up. Now that the results are here, I can start to address the questions. So our first question was, are there any isoenzymes in that list? So let's look at the list and let's start scrolling down slowly. What are the results? Everything is hexokinase 1. And we can see an isoform here that is from another animal, but in the human specifically, yes, we can see isoforms of human hexokinase 1 given here. It's the isoform 3, 4, and 2. So if I just copy that, so our answer to the question that we have, yes, we have 3 isoforms. And I can just paste the result in, and then we have it isoforms 3, 4, and 2 of the human hexokinase 1. Next is, what is the closest homologue that is not a variant of hexokinase 1? So that is not labeled as a variant of hexokinase 1. Now to find entries that are not named hexokinase 1, I can just scroll down slowly until I hit one, this one here, that is not labeled hexokinase 1, and I can copy and paste the name, and it's an uncharacterized protein. So who knows, in the end it might still be a hexokinase 1, but at least it's not mentioned as such in the results. How many paralogs do you find? So let's go back and see paralogs. What does it mean, a paralog? Well, it means in that table anything that refers to the same animal, right? So that would be Homo sapiens in that case. And if we start with entry number 1, that's hexokinase 1. What paralogs are there? Enzymes other than hexokinase 1 from the same animal. So that's still hexokinase 1. And after 6, we are coming to the next one. It's just the alignment. So there was nothing found in this search, or the way the search was done here. So we can conclude there are no paralogs in this hit. No paralogs found, let's put it like this. How many orthologs are found from horse? So I've already seen enzymes from many other animals. Let's just go to the top here and make a search for horse. If that's the question, horse, yeah, there's a gene name, F7BA85 subhorse, but that's of course not a reliable thing to search for, because names are often very arbitrarily chosen. So to look for horse, we can see its Latin name is Equus caballus. So I think just entering Equus will be a good search, and we can see how many entries we find for horse. So here's the first one, and there are 12 instances of that word equus found. So let's go through them one by one, and we have 1, 2, 3, 4, 5, 6. If if we continue, then these are the alignments, so they're just replicas of what we just saw. So there were 6 paralogs from horse. Homologs, sorry, these are of course another animal, so there are 6 homologs from or in horse. Find the closest match over HK1 in Xenopus and view the alignment with the human protein. And then the question is, how similar are they? So let's go back and search that page for Xenopus. So we do find some entries. Closest match is this one here. Q6 GQB4 HK1A protein Xenopus levis. And if we go here to this one, to its alignment with the human protein, we can view the alignment and we can check how similar those are. So what we find here is that if we enlarge that a little bit, that for all practical purposes, these two are essentially the same. Give and take a few differences, these will have so much overlap that we cannot but conclude that these are very, very closely related. And we can put that into our result page. And the question was Xenopus HK1 very similar. 2. Perform the blast search again, this time against the plant database. What is the plant name in the first hit and what percentage overlap does it have? So to do a search against the plant database, what we do is we enter a new tab, go to UNIPROT, find human hexokinase 1, take the one that we know already. Now we want to do a blast search in a different database. We need to go to the advanced options. If we go to the advanced options, then below the sequence we can find the target database has a couple of choices, and specifically we can search in the plant database only. So we can now hit the run button and have to wait a couple of minutes while this window keeps refreshing for the results. And now that we have the results, we can have a look at it and we can see, yes, there's one on a certain plant, which is Artemisia annua. And if I just take that, copy that, we can see this is our first hit. So this would be the closest relative in a plant. And the identity here on the right hand side is 35.4%. So we take that and bring that back into our template. So the result, the plant is the hexokinase from Artemisia annua, and our overlap was 35.4%. Three. For comparison, align your sequence of the human hexokinase with a randomly chosen sequence. And the example given, which we can try, is TPA human. And how similar are they? So what will we do to do an alignment? What we can do is actually open a new tab in UNIPROT and go to align. So on the top left here is the align button, and if we say align button, we can put in the identifiers. So the identifier for human hexokinase 1 is HXK1 human, And the identifier that we were asked to choose is TPA human for this other protein that we want to compare to. And we can have it run in a separate window, and if we click the Run Align button, the new window will open, and we have to be patient for a while to get the results. Right, now that the results are here, job is completed. We can have a look at it, and if you want, you can take a screenshot. But the main result that we get is that these two sequences have coincidences indicated by asterisks or stars, and these are very few. And for all practical purposes, we consider them to be random overlaps, and we can see that apart from a few of those, there's essentially no similarity between those two sequences. So we can go to our tab and conclude that these two sequences are very dissimilar. And finally, blasted UNIPROT to identify an unknown sequence. Consider the following sequence of an unknown protein. Go to UNIPROT, perform a blast search, and then answer what is the name of that protein and how high is its scoring. So to do that, we need to copy that sequence, just the characters, make a copy of them, open a new tab, find UNIPROT, and in UNIPROT run a blast search on nothing but that sequence. So I've copied and pasted that sequence into here. I go to the original UNIPROT database, and with nothing else chosen, I click Run Blast, and as usual we have to wait a few minutes to get our results. Okay, now that we have received our blast results, we can look at them and we can see there's a number of instances found. All essentially agree on the enzyme found. Excuse me. So we are pretty sure that we found the right one, and it's the L-serine dehydratase from Thermus thermophilus. So if I copy that name, we can also see the percentage overlap. It's 98%. So the answer to that question would be enzyme found. Its name is Thermus thermophilus, and the answer to the overlap question was 98% overlap. And that concludes our exercise.